right. Hello, everyone. Welcome to Munro Live Podcast. I'm Al Steyer, Vice President of Technology and Research here. And with us today, we have Scott Barraclough, who is the Senior Product Manager for e-mobility at Mack Trucks. We're going to be talking with him for the next half hour, 45 minutes, and get into some interesting things with what they're doing in the e-mobility sector. So, Scott, would you like to do a quick intro to it for us?
Oh, sure. Well, hello, everybody. I'm Scott Barraclough. I am a product manager for e-mobility with Mack Trucks. So I've been working with our electric truck side for about going on 6 years now. And before that, I was involved with all aspects of the truck, really over 30 plus years in the industry. Most recently, I've been involved heavily with the powertrain side, but more on the legacy side with diesels, automated transmissions, electronics, that kind of thing.
So you said you just recently moved into the e-mobility. So, with that in mind,
5 or 6 years recently.
Yeah. So,
speaking, I guess.
Thinking about the transition from 20 years ago to today, what have you seen as the biggest things that have happened?
Biggest things, I think, from back when I started, electronics, really. When I started, in the early 90s, in some cases, the radio was probably the most advanced piece of computing equipment on the truck.
Everything else had cables attached to it.
Yeah, exactly. We had mechanical engines, still did a lot of those at that time and everything. But, as time has progressed, look at the technology that's on the engines, fuel injection systems and all that, to the emission controls, look at the automated transmissions, all the safety systems, heck, the infotainment that's on the trucks now. They are very, very high tech from the electronic side compared to when we started.
Yeah, so even on the emissions, that really took a big jump, about 10 years ago, maybe 15 years ago?
Yeah, being on the powertrain side for 20 years like I was, there were several big steps there, and I was along for a lot of them, and it certainly presented their challenges going through there, from 04 through 07, 10, 14, on and on.
So were you involved in the diesel emission fluids aspects on your truck?
Sure, that was 2010 when we added the selective catalytic reduction, the SCR systems to the truck. And actually as those technology implementations go, the SCR was actually pretty smooth, relatively speaking.
Okay.
It wasn't perfectly flawless, but it went very well, comparatively speaking. Fortunately, SCR had been used elsewhere in the world. So, being part of a global organization as Mack Trucks is, part of the Volvo Group, we were able to leverage the experiences of our counterparts on the other side of the pond, bring a fairly mature system onto our trucks. And that went pretty smoothly, all things considered, but if you take a step back, or a couple steps back, when you started looking at DPFs on trucks or EGR on trucks, we were the trailblazers, we're pioneers in North America, and those products had their growing pains associated with it.
Yeah, I remember when that first came out, I ended up doing a benchmarking project on it, and I want to say every OEM had a different approach on how their tank and the controls and their strategies. It was just, it was fresh in the market, and everybody's, what do I need to do to meet the requirements? So thinking about that with all the telematics and, safety systems, how's your expertise shaped your approach to developing the electric truck? I'm sure that had some influence on it when you started looking at electrification.
Yeah. On the one hand, electric trucks, it's a whole new ballgame. The powertrain's completely different from what we've been doing on the diesel or even natural gas side. But on the other hand, it's still a truck that's got a job to do. All right. In the case of Mack, our first entry into the electric market was a refuse truck, garbage truck.
All right.
Still got to pick the trash up every day. Ultimately, that's why they're buying the truck. So,
yeah. Well, get them to come by my house. They seem to skip my house every other week or so.
But, Mack, we've been building trucks for 125 years now. And there's a lot of knowledge about trucks and what they need to do. And we've gotten pretty good at it.
You just transitioned to the e-mobility group about, was it 4 or 5 years ago? So
yeah, like right around the end of 2019.
So, How has that transition been for you, whether personally or professionally?
It's been interesting to say the least. I've enjoyed it. It gave me an opportunity to look at something new. I've been working on, the traditional side for, like I said, probably 25 plus years at that point. And the opportunity presented itself where where they needed someone on the e-mobility side. And I kind of jumped at it because it was something new, exciting, and, looked like it really had some potential to make an impact. It was humbling, I'll say that, having to, I thought I knew a lot about trucks. The first couple of meetings I sat in with on the e-mobility side, it was humbling. I was lost. You really had to relearn the whole powertrain system from the ground up. Very little carried over. So that was interesting, and there was a learning curve there. But I think we got through it pretty quickly.
Yeah, the way it carried over.
A lot of help.
Yep, the tires carried over, maybe some shafts, maybe a differential. Other than that, yeah, you pretty much take out the whole thing and throw it away.
Yep. And you're starting over. But that was interesting. I could say I learned a lot. And it applies to a lot of things you see. Even looking at the electric cars. The concepts are very similar, regardless of what kind of vehicle you're looking at. It's just a matter of the components and how they're implemented. But they have a lot of the same core components and follow the same concepts.
So, thinking about it, how do you guys balance, maintaining your legacy in the trucking industry as you move forward in electrification?
We're going to have both. There's, for, the short to near term or short to midterm future, for sure. Diesel trucks are not going anywhere in the near future. It's not going to happen. It's not practical. The infrastructure's not there. I'm sure we'll talk more about that here in a bit, but where it fits, that's kind of where we're starting, and as the technology improves, infrastructure improves, marketplace acceptance becomes more, we'll be able to expand into other applications, and, the product will become more viable across a wider range of applications and customers.
So did you guys also design the refuse side of the vehicle, or do you just do the vehicle itself?
When you say the refuse side, we make the chassis. The bodies are made by another company that specializes in refuse bodies. But we make the chassis. But if you look at the refuse truck, it is our traditional diesel chassis. So we had a very strong foundation to start with. We are a market leader in the refuse industry, and the LR chassis that we have has done very well. It's a purpose-designed refuse vehicle. So we had a very solid foundation to start with when we did the LR electric. And so, we started with that chassis and then ultimately integrated the electric powertrain onto that chassis.
Okay. So the dumpster section of it, the compaction and all that, is that yours as well, or is that?
No.
Okay.
No, that is typically a body company that does that install.
Okay. So can you kind of walk us through the development process to get to the electric truck that you're currently making?
Sure. It was, again, we were starting from zero. There was no electric trucks out in the market at the time.
Yep. Kind of hard to benchmark something that's not there, huh?
Yeah. And, fortunately, when we started, we had a customer, a very good customer, Department of Sanitation with the City of New York, was very interested in electric trucks, and they had sustainability goals to which these electric trucks could certainly be part of their plan. So in 2019, we announced our intention of doing an electric truck. And this whole project, from delivery standpoint, was really worked at a very very fast speed, relatively speaking. We went from announcing in 2019. 2020, we had a prototype truck in our booth at the Waste Expo, which is a big industry show. And then 2021, we had a production unit there.
Oh, that is quick.
To go from an announcement to a production unit in 2 years, you really have to take your hats off to the project. But, when you start talking about the commercialization, sometimes you look at it and, the truck may be the easy part. It's all the other stuff that goes with it. And I use that word a little bit lightly. But if you look at it, there's a whole ecosystem, that goes with the electric trucks that you maybe don't think about with your diesel product. You've already got diesel pumps and, all that's been around for 100 years. When you start going to electric trucks, okay, now you need charging. Okay. And then also, what's going to happen if something goes wrong? You need to have the dealership and, the support system there to support the trucks. And, some customers are nervous about going in there. So we have some, uptime solutions there for the customers. Operational support. We need to look at their operations. We understand that, the electric truck is not a one-to-one replacement for any diesel truck that they have in their fleet. So, we have to help them, identify opportunities for where the electric truck is going to work well. So we have some route tracking and route analysis capability that we can do with the customer to really identify routes where we think the truck's going to work. You have, again, working with utilities because, sometimes the customers have the energy necessary coming into their facilities. Sometimes they don't, and when they don't, you have to work with utilities to get it there. So, there's this whole ecosystem that you don't even really think about, on the traditional side that you now have to bring into play, and it took a really strong group effort on the Mack side to get people in place and expertise in place to support the customer throughout that entire ecosystem.
Oh, yeah, that's definitely a challenge. Yeah, definitely a challenge here. We've got an Amazon distribution center just down the road from us, and it's like, just thinking about how many electric vehicles do they have? Because they're delivery trucks, and I want to say they might have had like 40 charge stations set up, just like you said, the infrastructure to support that. And then, what do you have on site? When do you charge it? How do you use it? The use case scenarios, So, when you said 2 years, how much testing did that allow you in that time frame?
It was definitely a condensed time frame. Fortunately, a lot of the e-mobility technology, again, being part of a global organization like we are, we were able to work with our partners and others in the company to take technology that was already in production in other applications. If you look at the powertrain, that really started out with our bus group.
Okay.
City bus. So, the motors, transmission, that technology was already there and fairly well proven. What we were concerned with, we had to do some durability testing because, think of garbage truck. Garbage trucks leave hard lives.
Oh, yeah.
Especially when you start looking at one of our very good partners, DSNY, City of New York. Those trucks really leave difficult lives. They are going all the time. So, we had to do some additional testing just to verify, the durability of the vehicle in a more harsh environment. But, everything was passed, fortunately. And, we were able to get that into production with a high degree of confidence, the quality that our customers are going to receive.
So, you mentioned leveraging, your partners probably like overseas, over in Europe for the, the bus, for the motors. Do they actually make the motors over there, within your partnership, or are you making them here?
Components are coming from the European side. Core components, they come here and then they do some upfit of them before they go to our factory. We have a powertrain facility, same factory that makes our diesel engines and transmissions. They do some work with the electric components as well, getting them, call it staged to be installed at the truck factory.
So, some pre-assembly and things.
Yeah,
you're not actually doing any windings or putting the rotors in. That's already pre-assembled. Yeah.
Yes.
All right. What about the battery?
Battery is, we don't make the battery ourselves. They're designed to our specification and provided by a supplier.
Okay. So when you say to your specification, you call out like the BMS and the thermal system management, or are they?
Yes.
Okay.
Yeah, that's all done in cooperation with the company, with the battery provider. And, we were able to work with the same company that they were overseas. So, a lot of that was already done. The battery company has opened up a facility here in the United States. So the batteries are manufactured here in the States for North American consumption.
All right. Yeah, it reduces the shipping for sure.
Oh yeah, and in batteries, these aren't double A's.
No. So what form factor are you using? Using a prismatic?
I believe so, yeah. And it's, they are rectangular batteries. We have 4 of them on the truck. In their current state, they're 94 kilowatt hours each. So we've got 376 kilowatt hours on the vehicle.
All right. Yeah, I was curious about that. And so, like, you got 4, and they're tied in series?
No,
No?
they are, I guess you would say, they all go into a central control unit that then distributes the power from the batteries to the rest of the vehicle.
Okay, so each battery pack is 600 volts in. Each
They're
of the
all
4?
operating. Yes.
Okay. All right. Yeah, so you're running them in parallel.
Yes.
Yeah. So if, I guess on a redundancy, if you lose one, you still got 3 more in that scenario, but then charging afterwards might be a little bit challenging.
Yeah, and then your range goes down 25% or 50% or whatever, and so that's generally a problem. So, yeah.
So we've worked on a lot of electric vehicles here, and just thinking like of thermal systems. Are you guys able to leverage any or scavenge any heat off of the electronics or the battery to support like cold weather, climate control for the cabin or anything along those lines?
Yeah, sometimes we can get a little bit, we are, the cooling system, I say cooling system just out of habit, but it's really a thermal management system, right? Because, it cools them in the summer and heats them in the winter, keep the batteries at their happy place. So, we are able to get some heat from the batteries, motors, that kind of stuff. But, I think a lot of the energy, or a lot of, like the cabin heating, especially, for instance, it's on its own circuit to make sure that you get ample heat.
Right. So you're using PTC heaters for the cabin?
Yeah, it's resistive heat right now.
Yeah. Yeah, I've seen quite a few different approaches with thermal systems. I did find one company that inadvertently was scavenging heat from the system and putting it into the cabin, but I don't think they realized what they actually did. But
yeah, I mean, that's great in the wintertime. In the summertime, it probably doesn't work, keep the guys so happy. But
yeah, I've looked at a lot of the thermal systems, like the Tesla, the Ioniq, the Hyundais,
yeah,
the Fords.
we're starting to see heat pumps, and I think ultimately that's a better solution, but there's a lot of integration work and a lot of development that goes into that.
Yeah.
And,
Yeah, I know there's a few companies out there trying to just create a package that's just plug and play for the heat pump. So that could give you some options as far as what you do moving forward in the future.
Sure.
So I noticed it looked like the batteries. I was looking at the, actually I can do this.
Okay, sure, yeah.
I did
Spec
pull
sheet
it up.
there, yep.
And it looked to me like the batteries are just sitting right here, right behind the cab.
Well, you have 2 behind the cab, and if you look under the body on the driver's side there's also 2 more batteries mounted on the side of the frame there as well.
Okay.
So yeah, but they're all 4 identical, same part number. They're just mounted that direction. When we did that, we wanted, because initially we wanted to have a one-size-fits-all solution, and we focused on 2 applications to start. We focused on the rear loader, which was on the picture that you're looking at. If you think about that, that's where you have a helper that runs along and takes the can and throws the garbage in the back of the truck. And then we also looked at the automated side loader. And if you look at a side loader, that's the one that has the arm that goes out and grabs the can and dumps it in the body. And on the side loader side, automated side loader, we need the right-hand side of the truck to get clear, because that's where the arm is, And when you're driving down the road, that arm has to retract into the body in that area, so you can drive down the road when you're not collecting.
All right. So, I'm, like I said, I've seen so many. I'm very familiar with the basic powertrain side of it. What can you tell me about the refuse portion of it? The bin in the back. Do you have hydraulics on it, or has that been completely converted to electric?
Both. It really depends on the body the customer chooses to install on the truck. There are electric bodies out there. that are completely electric. You know, it's a side loader right now is the electric body that's out there. And, you know, it's electrified, so the arm is electric. But most of the bodies out there are still the traditional hydraulic body, essentially the same bodies that they put on the diesel trucks. Only now we have an electric PTO driving a pump to provide the hydraulic pressure, as opposed to a PTO mounted to the transmission of a diesel truck.
Okay. Yeah, I kind of was looking at it. I saw you had two motors, talking about a PTO. So one motor's for the PTO, and then the other one's...
Two drive motors, and then a third motor for the PTO.
So when you said you got two drive motors, is that like one per axle, or?
No, we have two drive motors going into a 2-speed transmission.
Okay.
We call it a power shift transmission. It's a very clever, very, very clever device, I think, from a mechanical standpoint, because you have two motors. We call it a power shift because one of the motors is always connected.
Okay.
We're only shifting one of the motors. That's the beauty of electric motors, is they don't have to spin at the same speed.
Right.
You know, it's not like pistons on a crankshaft with everything. They're all spinning the same speed. You know, when you look at the motors, they can spin at different speeds. The only time they're spinning the same speed is when the truck is stopped and they're not spinning.
Okay.
Otherwise, you know, so we have one that's got a low range. One of the motors has a low and a high range. You know, so you put it in low range for starting off, and then once you get moving up to speed, then it's just in the high, and then they're both spinning. They're not exactly the same gear ratio, but
so when you're in high range, then you're running both motors, or you shut one down?
Oh, you're running both motors all the time.
All the time. Okay.
It's just you get a lot more gear reduction on one of them when it's in low range. That helps to get you more torque to the rear axle for starting, getting the truck started.
Yeah, I've seen some, like e-axle, where the motor's right on the axle, and different approaches.
We still use a chassis-mounted solution. You know, e-axles are a very valid solution. But again, you know, we had some concern given the e-axles on the heavy-duty side that are out there when we were doing the project a couple of years ago. Just the durability in the refuse application was a concern. You know, we really didn't have any testing or anything on that. We didn't have one in-house, so we chose to go with one that's mounted to the chassis, and then we have to have call it a traditional rear axle. It's the same rear axle you would have on a diesel truck. You know, just a proven product there.
Yeah, so you just carry over from your current product line.
Yep. So from the drive shaft out of that transmission to the axle is the same as you have on a diesel truck.
Right. Yeah, so it reduces your total development time when you have all that. You know, so you just kind of plug in these new components and figure out how to make them work.
Yep. You know, making them work and then making them survive is also key. You know, like I said, refuse trucks have hard lives. You know, and so we've got to, you know, the quality has to be there. You know, like customers need a truck that runs.
Yeah. So I see you have like a 12 and a 24 volt system as well. So 12 is what? Your basic infotainment, cabin controls?
Yeah, it's the cab controls, lighting, you know, those components that are carried over from the diesel side, you know, that's all 12 volts. But most of the electronics on the truck controlling the drivetrain, that's all 24 volts, as are your electric air compressors, your electric power steering pump, and the electric air conditioner. It's a roof-mounted air conditioner.
Your air conditioner is 24, or is that 600?
It's 24.
Really? Have you guys looked at bumping it up to 600?
No, I don't know of really a 600 volt air conditioner. This was a nice solution. Again, it's kind of a drop-in solution, and, you know, similar to what you might see on an RV or something like that. You know, it comes with 12 and 24 volt. The 24 volt's more efficient, so we went with the 24 volt in this case. Plus we had readily available 24 volt power.
Yeah, I was just thinking with the 600, because pretty much all these EVs that we've torn apart, they all have high voltage air compressor or AC compressors on them. They're using scrolls.
Okay.
There's a lot of them out there. You know, whether it's a heat pump or if it's just every manufacturer is a little different. Like, I mean, GM is a perfect example of how to teach somebody about thermal systems requirements in an electric vehicle. They had 3 systems, one for the cabin, one for the battery. Battery's just like you and I. In wintertime, it wants heat, and then when it's hot out, you want to be cooled. And of course, you just have the electronics where you're just trying to remove heat.
Yeah. It's funny you mentioned GM. I was just watching a video on them the other day. They were talking about their the Hummer EV that they did, and they did some talking about the thermal management I found pretty interesting. Like, in fairly simple terms, but just talking about how they moved heat around the vehicle, from the batteries to the cab, like you were talking about with the heat pump and that kind of thing. It was pretty interesting, the things that they were able to do with that.
Yeah. You know how much that battery pack weighed in that thing?
In the GM,
Yeah, the
or
Hummer.
like on the Hummer, I think they were saying like over 3,000 pounds. I believe they said in the video.
2,450.
Okay.
The whole truck weighs like 9,000 pounds.
Yeah.
We got a 12,000 pound hoist in the back, and when we had it up on it, I have never seen that hoist come down so fast as it did with that truck on it. It's like you did not want to be underneath it when you hit the down button,
Oh,
and
I
hope
can imagine,
and hope one of the locks doesn't stay latched, because that other side's coming down quicker than you think.
yeah. Whew.
Yeah, and it was actually pretty interesting. They were running. They could actually hook up it's actually two 400-volt cell or 400-volt modules inside, one on top of the other. And they could charge at 800, but normal operation, for driving down the road, it would switch to 400 volt. But yeah, it had more contactors in it than most of the other vehicles I've ever looked at. So. All right. What else was I looking at? So you say 3-mode regenerative. What do you mean by 3-mode?
Well, again, being a truck, we try to keep it familiar for the operator. The cab itself is very similar to what you have on the diesel truck. The controls are all very similar. And most of our operators are used to having an engine brake on a traditional diesel truck, which helps to slow the truck down and, works when you take your foot off the throttle. And we worked our regenerative braking strategy to be very similar to that. So you have two settings. You have a high and a low setting. Actually, 3 settings, but 2 settings, high and a low, which work like a traditional engine brake on a diesel truck, which the drivers are familiar with. And again, we didn't want to go crazy. These are garbage truck drivers. We don't want to have it, have a screen in the middle that controls everything. And that was too much of a departure. So, they took the foot off the throttle. The regenerative braking comes on.
As you take your
just
foot
like-
off the throttle, right?
Yeah, when
Yeah.
the
Okay.
computer sees 0 throttle pedal, then regen comes on when you're in the high or low setting. Then we have an auto setting as well, which doesn't bring the regenerative braking on until you step on the brake pedal, and then it blends the service brakes in with the regenerative braking. If you think about a refuse truck, there's a lot of opportunity for regenerative braking. In residential collection, you're stopping and starting 800,000 times a day.
Yeah. When you get to the dump, you come back down the hill and you recharge.
Right. You use the energy going up it. So
Yeah.
it's kind of a wash. But yeah.
Yeah.
But so you have a lot of, so that's, it doesn't take a lot of training to get a driver up to speed on the electric truck, but that is one very important concept that we have to work with the operators on to make sure that they understand, that they're using the regenerative braking properly, because, when we look at the data, the regenerative braking generally is 20 or 25% of the energy that you consume over the course of a day, you get back through the regenerative braking. So if you don't use it properly, you're going to see a substantial hit in range. Range, like any electric vehicle, that's key. We've got to do everything we can to maximize the range on the trucks.
Yeah, it's kind of interesting talking about regenerative braking and whatnot. Back in the early 2000s, EE Times, hired us to help them do a teardown on the Chevy Volt with a V. And they actually bought 3 cars. They sent one here to our facility where we took it down to bits and pieces to, go to the show in San Jose just to talk about the inputs, outputs, different things in the modules. One of the cars they drove across country, and part of the trip, one of the things they did is they took it to Pikes Peak. Are you familiar with that? Where the big hill, the big mountain where they race up it?
Yes.
So it was him and his brother. His brother was a photographer. He said by the time he got to the top of the hill, it's got the engine in it, so it's basically a generator. His brother got out of the car and was walking as fast as the car was moving. It just slowed down so much. It basically drained the battery. And then when he came back down the hill, he said I think he said he got like 80-90% of his charge back on the trip back down the hill. So like you said, you get, you recoup it coming back, but going up, you lose it, and so on. All right. So, like talk about like industry trends and challenges. Trucking industry has unique demands, and we kind of talked to a lot of that. But what have you found to be the biggest hurdle to widespread electrification?
The infrastructure is certainly going to be one of them. If perhaps not quite as much with the refuse side. We also have a medium duty electric truck as well, and they're both fairly similar from the standpoint that customers have made it clear they want to go a whole shift on a charge. They don't want to take a truck down in the middle of the day. And that was kind of one of the things, I don't know that necessarily surprised us, but we hadn't quite expected that. We thought they would be more open to midday charging where it was needed, but they made clear they want to go all day. Okay, so we do have put more energy on the truck, but those trucks, our trucks, they'll charge at home. They're not going to use public charging. They'll have infrastructure at their facility. They park the truck same place every night. It sits there all night, so you know where to put it. You know when it's going to be charging. So from that perspective, it works well. But going forward, as you venture out into other applications, you're going to need opportunity to charging outside of home base. And on the truck side, that barely exists today. There's probably 3 or 4 operating truck-specific charging stations in the country right now. It's just not there. We are working with groups within the Volvo group. There's a Powering America's Commercial Transportation, what they call it a PAC coalition, to set up infrastructure corridors. But that's still
it's years down the road.
Yeah. So the infrastructure is a big one. The capability of the vehicles, range, how far can it go? Right now with the battery electric vehicle, somewhere between 300 and 500 miles is what you're going to get maximum out of a battery electric vehicle right now. And
You talking about passenger car or yours?
no, battery electric vehicle truck, yes, like an over-the-road truck.
Yeah, because I thought I read where it has like 100-mile range typical.
Well, if you look at a refuse truck, it's a little different than an over-the-road truck. We're not just going A to B. We're going A to B and stopping 800 times in between to do work. So if you look at our range from a mile perspective, it doesn't look that impressive. But if you can do 100 miles and 1,000 pickups in between, now that's a little more.
Right.
It looks a little more impressive, than just going 100 miles on a charge.
So what kind of customer acceptance have you seen? Is that an issue that you've had to overcome? I think you said you had a customer come to you asking about it first. So.
Oh, yeah, it was the city of New York. Yeah, and customers that have the trucks really like them. The operators especially. If you look at that, if you think about a garbage truck, you're sitting in the cab and the diesel engine is right here. It's an armrest.
Yeah, and it's noisy.
And it makes noise, and it makes heat, and it makes vibration, and you don't have any of that in an electric truck. So the operators get in there, and it's a revelation. It really is. That's the first thing they notice when they get in there is they can't believe how quiet it is. We jokingly call it our electric golf cart because that's kind of what it sounds like. The other thing they notice that they really like is the acceleration. The electric motors, they make their maximum torque at 0 RPM. So when you step on it, it goes right now. You're not waiting for torque converters to hook up or turbos to spool up. You step on it, it goes.
So they're out there in the parking lot doing donuts right now with the snow?
Almost. But no, we've got traction control and other algorithms in there, keep them from doing that. But yeah, if turn that stuff off, you can do some fun stuff.
So How did like regulations and government incentives how have they impacted the electrification for trucks? Have you seen any big changes there?
No, I wouldn't say big changes, but they are key at this point. I mean, the cost of electric trucks is significantly more than traditional diesel counterparts. So, I mean, to get trucks going into customers' hands, just about all the trucks that we've done, they'll all have some kind of incentives or grants or something associated with them, just to get in there. If you look at the business case, there is a business case, but it's a bit longer than what customers are usually looking at as far as payback.
Yeah, for ROI.
For ROI, yeah. Yeah, so, that's where the incentives help to equalize some of that out. Because the operating costs are certainly less, but, the acquisition cost is significantly higher. So, you've got to help equalize that out.
Yeah. So I know you talked about telematics and, data acquisition, things like that. Do you guys have like over-the-air access to this data, or is it just stored locally on the trucks? And how do you?
No, we have a telematics system on the truck, so it's pumping out data constantly. So we have the ability to look at that data, see how the trucks are performing, and that's really been a key thing for us because we can work with our customers. They can view the telematic data, see how their trucks are performing, and it also takes a lot of the he said, she said out of if there is a concern about range or efficiency of the vehicle, you have facts to deal with, to drive the conversation. You're not just, well, this truck doesn't go far enough or whatever. We can look at the facts, and a lot of times we can see where there's potential opportunity to improve things. But we can certainly makes for a better conversation when you have both sides have facts in front of them that you can make informed decisions.
Yeah, and at the same time, you learn from the data, and you can make adjustments, whether it's software, hardware, or whatever the case may be, right?
Exactly.
And you said that the customer has access to the same data?
They do. I mean, we can provide it to them, or there are telematic systems out there that they can use, like telematic gateway systems that they can use to look at it.
Well, I think I only have one more question. How do you see the future of e-mobility evolving within the trucking industry over the next decade or so?
I think if you'd asked me the same question 2 years ago, I might have given you a slightly different answer. I think we were a bit more optimistic then. We've sort of had to temper our aspirations a little bit. However, saying that, we are still fully committed to e-mobility and, continuing to offer the electric products we have and bringing more electric products into the market going forward. Ultimately with the goal of having electric offer, or I shouldn't say electric necessarily, but a zero emission offer across the entire product line. Because if you look, we've pretty much just talked about battery electric vehicles, this conversation at this point, but, there are other zero emission solutions out there, which, especially as you get into longer haul applications that are going to have to come into play because unless there is a major breakthrough in battery technology, which we don't see probably in the next decade, or if it is the next decade, it will probably be towards the end of the next decade. The fuel cell electric vehicle is a viable solution. But again, it faces a lot of the same hurdles that you have with battery electric vehicles on the infrastructure side.
Yeah, we do a thing called EV Primer every now and then, and at the end of it, I go off onto the hydrogen side, and I got this crystal ball, but it's a muddy crystal ball. It's like, what direction is it going to go?
Right.
It could go, ice, or it could go, fuel cell. But same thing like you mentioned with the electric. The infrastructure is still not there. So.
Right, and I mean, I see there's a place for both, just depending on the application. But again, at least electricity. I mean, there's pretty much the whole nation's electricity. There's electricity pretty much everywhere in the nation. It's just a matter of getting it in the amount that you need to a certain place. Where the hydrogen infrastructure just is non-existent at this point. And it's a complicated way to do it because you can't pipe it.
Yeah, it doesn't
small
like that.
molecule.
Yeah.
No, so you either have to make it on site or truck it in, and there's just that all has to be.
All right. Well, I think that's pretty much all I got. If you got any other questions or anything else you want to offer up, we'd be more than glad to hear it.
Well, I do appreciate the time today, and I hope, people understand that we are committed, and, electromobility is coming. It will continue to develop, and you'll be seeing more and, improved products as time goes on from the industry as a whole, and, we certainly hope going forward that, we can maintain the momentum that we have at this point.
Yeah, I hope you do too.
Yeah.
All right.
Yeah.
All right. Well, I'd like to thank everybody for watching. Again, Munro Live Podcast. We're going to wrap up at this point and hope to see you in the next podcast in the future.